Hello, I'm here to show you how to solve equations using power series method, and we'll end up with an equation that can be transformed into a transcendental function. So let's start with an example then. So guys, let's try this equation. Let's try to solve this equation using power series method, wherein y is equals to the summation of Cn x raised to n infinity n is equals to 0, wherein it is equal to c sub 0 plus c1x plus c2x squared plus ellipsis, wherein ellipsis is equal to infinity numbers or infinity values. So derive this, have to get y prime. So by derivation we'll have is equals to 1 c ncn x raised to n minus 1 equals 2 c1 plus 2c2x plus 3c3 x squared plus 4c4x cubed plus ellipsis. So again, derive this equation, so we'll have to come up with y double prime. So as you can see, y prime to infinity n is equal to 2 n times n minus 1 cn x raised to n minus 2, where is equals to 2c2 plus 6c3x plus 12c4 x squared plus infinity. Now we'll have to substitute these values from the equation, wherein y prime summation of n times n minus 1 cn x raised to n minus 2 plus y, which is n is equal to 2, so 0 cn x raised to n is equals to 0. Okay, now we'll have, in order for this to be solved, we have to have the same x values. So we'll have to subtract 2 here in this part and add 2 in this part. So that will have to come up with n plus 2 n plus 1 c n plus 2 x raised to n plus e summation n is equals to 0 cn x raised to n is equals to 0. As you can see, the values of the variables is the same, so we can factor it out as summation is equals to 0 n plus 2 n plus 1 Cn plus 2 x, no, x raised to n, I have to remove it outside, plus Cn is equal to 0. Okay, sorry about that. Now we'll have our recursion relation by solving this and equating it to 0. So we'll have Cn plus 2 is equals to, transforming it out, negative Cn over n plus 2 times n plus 1. So this is our recursion relation now. Now we'll have to substitute values of n from 0 to other terms. So let's see what we can get. So if n is equals to 0, we'll have C2 is equals to negative C0 over 2 times 1, that is negative Z0 over 2 factorial. If n is equals to 1, we'll have C3. We'll have C3 is equal to C1 over 3 times 2. It can be simplified as C1 over 3 factorial. If n is equals to 2, we'll have C4 equals to negative C2 over 4 times 3, wherein it can be simplified as negative C sub 2 over 4 factorial. If n is equals to 3, then we'll have C5 is equals to negative C3. Oh, it's negative here. Negative C3 over 5 times 4, wherein it can be simplified as C1 over 5 factorial. C1 because as you can see, it can be transformed. C3 is equal to negative C1 over 3 factorial. And it is substituted here, so it will come up with the positive value. So if n is equals to 4, we'll have C6 is equals to negative C5 over 7 times 6, wherein it can be equated as no 6 times 5. It can be equated as negative C0 over 6 factorial, and also here it can be C0 over 4 factorial. So that will have a pattern now. Okay, we'll try it until n is equals to 5. If n is equals to 5, we'll have C7 equals to negative C. So it's 4 here. C4. So C5 over 7 times 6 is equal to negative C1 over 7 factorial. So as you can see, the patterns we have included will now separate the even coefficients to the odd coefficients. So, even coefficients. C2n is equals to negative 1 raised to n CO over 2n times factorial. Odd coefficients will be C2n plus 1 equals to negative 1 raised to n C1 over 2n plus 1 quantitative factorial. Now let's try to transform our equation from the original equation wherein y can be equal to C0 times 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x raised to 4 plus infinity. It's pattern of even coefficients plus pattern of odd coefficients wherein C1 is x minus 1 over 3 factorial x raised to 3, right, plus 1 over 5 factorial x raised to 5 plus ellipsis, so that we can conclude we can transform these patterns into transcendental function wherein y can be equal to CO cosine x plus C1 sine x. This equation now can be transformed into y is equals to CO cosine x plus C1 sine x. Okay, we're done with the first example. Let's try another example of our series. So let's have y double prime is equals to y. So let us have the value of y to Cn x raised to n is equals to 0 equal to C0 plus C1x plus C2 x squared plus C3x cubed plus ellipsis. Let's derive it, so that we'll have y prime is equal to summation of n Cn x raised to n minus 1, n is equals to 1 to infinity, and let's derive it again to y double prime is equal to summation of n times n minus 1 Cn x raised to n minus 2 from n is equals to 2 to infinity, and we'll have to substitute this and the general equation. Now let's substitute this. Y double prime is equal to summation of n times n minus 1 Cn x raised to n minus 2, and is equals to 2 to infinity, is equal to summation of C sub n x raised to n is equals to 0 to infinity. I have to transpose this equation to the other side so that we can equate it to 0. N minus 1 Cn x raised to n minus 2 minus the summation of Cn x raised to n is equals to 0 infinity equated to 0. Now we'll have to subtract 2 here, subtract 2 in order for the variables to have the same value. Subtract 2, and we'll have to add 2 here, so that we'll have value of n plus 2 n plus 1 Cn plus 2 x raised to n minus n is equal to 0 Cn x raised to n is 0. Now we'll have to factor out the variables that have the same value, is 0 here, x raised to n and the summation. So we factor it out like this. X raised to n plus 2 n plus 1 Cn plus 2 minus Cn equated to 0. Now from this equation we'll have to form the recursion relation, which is n plus 2 n plus 1 Cn plus 2 minus Cn is equal to 0, wherein Cn plus 2 is equals to Cn over n plus 2 times n plus 1. Now we'll have a recursion relation. Let's substitute the values of n. If n is equals to 0, we'll have C2 is equals to CO over 2 times 1, or can be simplified as CO over 2 factorial. Now if n is equal to 1, we'll have C3 is equals to C1 over 3 times 2, or can be simplified as C1 over 3 factorial, and n is equals to 2. Same pattern. N is equal to 3. Substitute the formulas. C6 equals C4 over 6 times 5. Be simplified as 6 factorial, CO over 6 factorial. And n is equals to 5, C7 is equals C5 over 7 times 6 can be simplified as C1 over 7 factorial. All in all, we'll have a value of y is equals to CO plus C1x plus C2x squared plus C3 x cubed plus infinity for even coefficients. Could be written as C2n is equals to NCO over 2n factorial. Add coefficients. Could be written as C2n plus 1 is equals to C1 over 2n plus 1 factorial. Now we'll have y is equals to C sub 0 1 plus 1 over 2 factorial x squared plus 1 over 4 factorial x raised to 4 plus infinity plus C1 x plus 1 over 3 factorial x cubed plus 1 over 5 factorial x raised to 5 plus infinity. Have these equations can be transformed to transcendental functions and can be simplified as cosine hx plus c1 sine hx. So this is the answer for the differential equation y double prime is equal to y. Now let's have an example of the multiplication of power series, wherein we'll have sine x ln of 1 minus 2x up to x raised to 4. Let's start with substituting the values of transcendental functions, wherein sine x is equal to x minus x cubed over 3 factorial plus equals to x minus x cubed over 6 plus, we just have to factor out the 3 factorial. We're in 3 factorial is equals to 3 times 2 times 1 is equals to 6. Now let's have the value of ln 1 plus x equal to x minus x squared over 2 plus x cubed over 3 minus x4 over 4, wherein we'll have ln 1 minus 2x equals to negative 2x minus negative 2 x squared over 2 plus negative 2x quantity cube over 3 minus negative 2x raised to 4 over 4 ellipsis, so it is continuous. So we'll have, simplifying these equations, have negative 2x plus or minus 4x squared over 2 minus 8x cubed over 3 minus 16x raised to 4 over 4, and it has a pattern, so again it is infinity. So simplifying this equation, we'll have 2x minus 2x squared minus 8x cubed over 3 minus 4x raised to 4 plus infinity plus ellipsis. So multiplying these two, we'll have sine x times ln of 1 minus 2x have x minus x cubed over 6 minus 2x minus 2x squared minus 8x cubed over 3 minus 4x raised to 4. Distributing this equation, we'll have answer of x times 2x minus 2x squared minus 8 over 3x cubed minus 4x raised to 4 minus x cubed over 6 times ln 1 minus 2x, which is negative 2x minus 2x squared x squared minus 8 over 3x cubed minus 4x raised to 4 plus, simplifying this equation, we'll have negative 2x squared minus 2x cubed minus 8 over 3 x raised to 4 plus x raised to 4 over 3 and so on. We'll have sine x ln 1 minus 2x equals negative 2x squared minus 2x cubed minus 8 over 3x raised to 4 plus x raised to 4 over 3. We'll have negative 2x squared minus 2x cubed minus 7 over 3 x raised to 4 plus. This is the answer. Convert this to 1 minus 2x. Convert this to converges for negative 1 to x.